hit record. Where's my team at? Thanks for sharing that other certification group. Do you have control that you can share your screen? Yep, awesome.
Yes, perfect. All right. Hello, everybody. My name is Vikram. I run a company called Omni Labs. We do process automation. So anything that you can do inside a web browser, we automate that for you. I'm also a Google developer expert for cloud and machine learning, and I'm happy to be here today to talk to you about BigQuery. So just a plug before we get started. We are hiring for different positions. If you are interested in any of these, come join us. My email is vikram@omni inc, and that's our link for our careers page. You can take a look at what we are building and how we are building it. And if you have any questions, always feel free to reach out to me on Twitter regarding company, not regarding company, anything else, general life advice. I might give bad advice, but I will give advice. Okay, so let's do a reintroduction. Um, Reintroduction, there's a Kiv. He's a rock star. This is my alter ego. Kiv is a rock star, and that's his symbol. He's just a very stressed rock star. The reason he's very stressed is because Kiv does not have any fans. So if you are a rock star and if you don't have any fans, you're gonna be stressed. So that's the reason for Kiv's stressness. Now, Kiv went on to google.com, searched through different places, and he found that the big data has answer to everything. So he's looking for answers now. Why does he not have fans? Or what can he do to get some more fans? So as looking around big data, he runs into BigQuery. He's like, oh, what is this? Let's give it a try. The query is not a really long query. This is an example that I found somewhere on the internet where it's like 5-6 pages of just a big long SQL query. I know some people who have done similar things, not these long queries, but long queries. So BigQuery is not that. It's more about other things, and let's dive deeper into that on the technical side of things. So now conversation switches back from Kiv to myself back. Okay, so what is BigQuery? I asked a few fellow experts and more data leaders around to answer this as a what is BigQuery, and they came up with several things which I tried to boil down into some themes. And one of the themes that is that BigQuery is a data analytics warehouse. So we see a lot of types of databases. You are aware of hopefully like document type databases. Mongo is most common one for that. Firebase is a real time database. But sometimes we need to use a database which is write once and it can do a lot of throughput. These databases are really huge, they can store a lot of data, and they don't really need a lot of oversight onto those. So BigQuery is a data analytics warehouse. Second, I have seen a lot of people use it for geospatial analysis. So BigQuery, since it can store a lot of information, you can store really large amounts of data in it, and generally large amounts of data involves some physical phenomena. In this case, geospatial data. So you can get your geospatial data, put it on BigQuery, and run analysis on that. It's also serverless and cost effective. Uh, just want to make sure. Okay, so we'll go by one on all those details, but just I'm giving an overview. So it's also serverless and cost effective, which means that you don't have to worry about the database management. Like there's thousands of servers running. You don't have to worry about the authentication through all of those. Of course, you make sure that you have the correct API key and you're using the correct account. But other than that, you don't have to manage all the backend IT part of that. Even the storage of data, like some of the queries that we'll show or we'll talk about today have like terabytes of data. You don't have to worry about where the data gets stored, how the data gets retrieved into the memory so that you can run a query on that. You don't have to worry about any of those things. And the last part that I really like about BigQuery, which has been true for a long time, is you can use predictive modeling on top of BigQuery to run your machine learning models. So I saw in previous slides that there was mention of like BigQuery as a add-on task that people can do as part of the study group. If you have done that, I think you must have gone through at least some of these, but it doesn't matter if you have done it or not. We will go and talk through some of these. So database. So generally, what kind of database is BigQuery? Let's go with that first. We talked about it as a data warehouse. So it can store all sorts of structured data. But what do I mean by structured data? That means that your data has to be in one of these formats. And I'm sure you're aware of most of these formats. Hopefully, you are. If not, you can ask me questions later when we end the talk. But most of these data formats you are aware of, and they are used across different databases as well. So if you have used any kind of SQL database, it uses these data structures to store the data. Notice this geography one in here, which is the one that you would use for geospatial data. The string sizes can be huge. You can also use time and timestamps, which are really amazing when you're trying to do queries on wide ranges or very small time ranges, where if you have a lot of data coming in, you can split it down into small time ranges. So now that's the storage of the data. But how do you now query that data? To query the data, you have to use SQL. And it's standard SQL that you use everywhere. There's no custom format to learn here for normal data queries. We'll talk about custom format when it comes to using machine learning queries, but for normal data analysis or anything in that arena where you're doing playing with data, creating data, and stuff like that, all of those queries are very standard SQL queries. So you don't have to relearn new things for a new database. The one thing that I mentioned this here is, like, in BigQuery, there's no editing allowed. So if you are used to normal databases, you can always go in and edit the value of a field or input row. You do like select something and you find that value and then you update that value. That is not allowed in BigQuery, essentially because that allows BigQuery to keep the operations fast. But remember, it's not a blockchain. Blockchain means the data is distributed across different devices. In BigQuery, the data is all co-located and Google manages all of the data. There's no proof of concept in there. There's no proof concept at all in there. The best part that I like about BigQuery is there's no storage constraints. You can give however much amount of data you have, and it will take all of that and it will use that to upload itself and then allow you to query on that. And we will go through some samples through there where we will see that storage constraints don't really matter much. So let's get started. Let's do the first demo. So I'm going to go slow so that everybody can get enough understanding. But if you have any questions, please feel free to ask me. And I'll be happy to answer them on the way. Okay, so this is how BigQuery page looks like. This is our project, no servers, because of course, no servers. We are going with everything serverless. This is my project inside which I can have a lot of things. So let's talk about them one by one. I can connect my BigQuery database with external connections. So I don't think I have anything in here, but you can connect this to an existing database that you have so that you can directly talk to the database using BigQuery. You can connect this to a storage medium that you have somewhere on your side or somewhere on AWS side. People have been using AWS for a long time, and if you have data storage there, you don't need to transfer all of the data to GCP. You can just connect to that data directly from here. Then there's part of the saved queries. Saved queries are useful when you want to when you revisit those queries time and time again. Of course, if you have a dashboard, you should use the dashboard so that you don't have to write the same query over and over again. But for dev use cases, generally what I do is I write some queries and I save them here, and those saved queries can be used over time. So I have some saved queries here that I'll be using throughout the demo, but just so you know how it looks. And then we have this demo collection, the demo data set. So this is our server, this is our project, and this is a data set. We'll come to the demo data set in a second, but let's talk about fail-safe data set. So this is the data set that I've created, just so like if demo doesn't work, if something is going on wrong, we can still go through our session here properly. So this is a data set which was created on August 31st, 2022. It hasn't been modified since, and its table expiration is never. So any tables that I create inside it don't expire ever. Let's quickly, we will come to demo in a minute. Okay, so fail-safe dataset has a few things in here.
Vikram, sorry, can you please
Yes.
zoom a little bit?
Zoom in a little bit. Okay, nice.
Yeah.
Definitely.
Thank you.
All right, let's do this. Okay, this is good.
Yeah, I think
Sure,
that's
thanks.
thank you.
Sure.
Perfect. Nice. Okay. So fail-safe, and then we have this fail-safe data set has a few tables in here. So let me just show you some examples in here. This is a hurricane table inside which we have what kind of field it is. These are all the different fields that are inside that table. What is the data type of that field? So like month is stored in string, average is a float, and every year has its own column, and which is an integer. So you can see all these different details in here. Let's see some more details. This was created on August 31st. It doesn't expire ever. There's only 9 rows of data. Not a lot of data in here. 808 bytes of storage cost. So this costs us in total 808 bytes. One good thing, if you are not aware about BigQuery, is after a while, what it does is if your data has been available or stored for over 6 months, it moves it into long-term storage. So rather than active storage, it becomes a long-term storage, and that costs even less. I don't remember what the relation is, like half or quarter. I don't know, but I don't remember, but it is. It gets reduced. So if you keep storing data over and over and over and for a long time, your data cost also gets reduced. So that's where it is. There are more tables in here, and then there's a model in here as well. So we have created a machine learning model. It's a linear regression model. It was all, again, created on August 31st, updated on October 28th. Simple model. We will do all of these things together today again. So let's start with the very basic thing. I'm going to delete this demo data set, and then I'm going to start from very beginning. Okay, so here's the no server. Let's close this. Here's our no server project, and I'm going to create a new data set in here. Generally, it's advisable to start a new data set when you're starting a new project, because inside that, new project as in like new project inside the company. So in this case, we are going to create a demo data set, but you can name it anything you want. As we are going through this, you can we will talk about almost everything in here, but if you have more questions about something specific, please always feel free to ask. We have a lot of time. Okay, so dataset ID is demo. You can put this into a specific region or multi-region. Doesn't really matter, but I'm going to keep it multi-region because why not? So data is available in multiple regions in United States. You can also move it to EU if you are an EU company and you have to worry about that. What I'm going to do is this amazing thing in here is I'm going to enable table expiration. So today, when I create this table and do all these demos inside it, it will be gone after, let's say, 7 days. So after 7 days, all these things that we'll be creating today will be gone. So 1 second, let me just do this. Okay, yeah. So after 7 days, all of those things will be gone. So you don't have to worry about cleaning things up and pricing and costs that I would incur and stuff like that. More options. Google allows you to, Google, of course, first of all, encrypts all the data on their side themselves, but the encryption key is managed by Google. So you're like, is it actually secure? It is secure, but like if the key is managed by Google, you can never trust that. So if you really need to manage keys by yourself, you can use customer managed encryption keys as well, where you have the secret key to decode all the data. Just so you know, like this is also very secure. I have never had to use customer managed encryption keys, but if you are a healthcare service or if you are some other kind of provider, your auditing firm might need you to use custom managed encryption keys. Case insensitivity and default correlation, nothing much in here, but if you have, these are like rarely people have to use these, but if you do, feel free to do that as well. Let's go in and create the data set. Okay, so our data set is now created. It's empty because there's no table inside it. And just so you know, it was just created and it will delete in 7 days by itself. Okay, now let's start creating tables inside it. So to create a table, I can just start creating table here. Just more things to know here. You can share this data set completely with somebody. You can do a specific views, specific routines. Don't have to worry about that, but like essentially you can share the data set and table with other groups inside your company or outside the companies as well. And I'll show that in a minute as well. Let's first do create table in here. So create table, you can create a table in multiple ways. Let's do the simplest one, which is creating an empty table, because why not? And we'll call this empty. When you create an empty table, we'll go through everything else. So we're creating an empty table in our project, which is no servers. The data set is called demo, and the table name is called empty. Table type is native table. We will talk about different types of table in a minute as well. partitioning and cluster settings, we are not going to partition it with anything, but you can partition your data by ingestion time. So I talked about BigQuery being serverless, but why is this an option then? Like, why do I have to worry about partitioning? It's a thing that database people have to worry about, but why do I have to worry about it if it's serverless? So the thing in here is it allows you to very easily figure out how can you reduce cost on your data, because BigQuery charges based upon the amount of data that is queried. So if you have partitioned your data by ingestion time and you run a query for last 7 days, then only last 7 days of data will be gathered to run the query. But if you haven't partitioned your data by ingestion time, then it will use the complete table. And then it will perform like the first thing that it will do is perform the filter. So for the first query, it will use the complete table. For subsequent queries that it internally does, it won't be using the complete table, but you will incur a big cost. So generally, it's advisable if you are going to be keep inserting data over time to partition your data by ingestion time, so that you can optimize your queries and they will use smaller amount of data. Queries will be faster. Your cost will be low as well. For us, we are not doing, our demo does not involve specific partitioning in here, or we are not going to be keep inserting data in here, so we'll just leave it with no partitioning. Advanced options, again, same as earlier, you can encrypt, you can do correlation, we don't have to worry about those, so we're just going to create this table. Okay, so we have an empty table in here. This is our table. There's nothing in the table, just so you see the details. We just created this table, and as I said, table will expire in 7 days. So we have the expiration date and time in here as well. So at this time, the table will automatically expire in 7 days. Preview, because since there's nothing in the table, there's no data to display. Lineage, this would be helpful for you if you had, I haven't enabled these APIs. It would be useful if you are creating the data automatically based upon some other table. So what you could do is you could run a query on another table to create this table. And that way you will be able to see the lineage of where the data is coming from and what kind of transformations are being applied on the data. Okay, that is generally useful when you're doing machine learning, because you really want to figure out how did your data get transformed into this n different ways. And lineage tracking is a big issue in machine learning when you're trying to build models and data changes and you don't know why the things change. So you need to be aware of the full lineage history. Okay, before we go any further, let me show you some existing tables. So this is what we did just now, created an empty table, but let's take a look at some other tables that are created by other folks. So as I talked about, you can share this. So here we have AccuWeather.com, which has shared a sample data set with us, with everybody, where you can come in and take a look. So this is a sample data set that they have created. Let me just go with the table first. So this is a table inside which there are a few things that they have shared. They have the city name in here with a date, max and min temperature, precipitation, and snow. So the reason, first of all, that AccuWeather has shared this is because they are trying to entice you to say, hey, this is the kind of data that we have. And if you want the complete data set, you have to come and like get pricing from us, and then you can use the complete data set. But they're essentially sharing the complete data set to you over here on BigQuery. Let's see some details around here. It's a very small table, 2,000 rows only, and it was last updated in 2017, March 9th. Not a lot of information here. Let's see some preview of the data. So you can come in here and see what kind of data AccuWeather has and is it actually useful for you. And if you want to use it, you can contact them and like get more information. So this is the sample in here, and you can see 2196 rows, and you can keep going, see the last few rows, see the first few rows. There's data for like few different cities. So we see New York City in here, and in the beginning we also saw Dallas in here. So this is a complete table. But what if you only wanted to get data for Dallas and you wanted to create the data and expose that to your team so that your team doesn't accidentally keep querying on New York dataset all the time when you don't need to? So this is called the table view. So this is a table view which was created. I think I should be able to see. No, okay. I can talk about it. So it was created from the sample table. It's a view on top of the sample table. That way, what it allows you to do, this is the query that was used. So they wrote the query where it's getting all the data from the sample column, but they split it only for Dallas data. So now when users make queries on this table, they will only see Dallas table. And also they limited the number of rows to 1,000 rows only. So that way, like it's an even smaller sample of the complete data set. And that's why you also don't see a lot of information here, is because it's a view. So it's a logical unit on top of the original sample table. That's why you also don't see a number of rows, anything in here, because all the data is actually stored in sample. But this is a logical collection which allows users to be able to make a query on top of a pre-filtered condition. You can do that as well here. So that's good. AccuWeather, in case you want to use that, you can go in here, and there are like other providers as well who have data on BigQuery. But I don't want to pay them right now. Maybe in future at some point if I'm using AccuWeather. So for now, what we will do is we will try to look at some other public data sets that are available. So BigQuery team gathers a lot of public data and makes it available for folks to use here. And we'll just take a look at some samples in here, and I'll take audience question to figure out which one should we use. So just so we know, there's Bitcoin data in here as well. There's black hole database as well in here. We have Census Bureau for US, Census Utility. We have Chicago crime, taxi trips, COVID-19 data. A lot of COVID-19 data is here available from different locations, different countries. There's a lot of crypto data for Dogecoin, Bitcoin, Ethereum, Polygon, whichever one you are looking for. AlphaFold, if people are not familiar about it, AlphaFold is a project by DeepMind where they try to figure out how do proteins fold. It's very important in drug discovery and figuring out how human health works. And all of the data is available here since DeepMind made it open source. So the data is available here. Actually, Ethereum blockchain is available here in case you want to look at that. GDELT is a book-based data set, so it's available here. They have a lot of book information in here. We have genomics data from Rice Institute. We have international ports, and we are only up till gene here. It goes for a long time. FDIC banks, in case you're interested, things that happened with Silicon Valley Bank recently. If you are looking for that kind of information, it's available here. FCC requires political ads to be available. FAA has airplane data. So essentially, a lot of data that is generally available, BigQuery team tries to get all the data over here so that you can see what is happening, how it's happening. One of my favorites is Hacker News. You can come in here and just query Hacker News whenever you want, rather than going to Hacker News and looking for this one specific thing. Of course, IMDb is used in all kinds of examples, so it's here as well. Patents information is here. Some machine learning data sets here as well. Moon phases. So actually, I'll take a question from us, a sample from audience, whoever wants to suggest me a data set to query on. Anybody?
I'm curious what that breathe data set was.
Breathe.
Yeah.
Breathe. Okay, nice. Let's see. I actually don't know. So let's see if they have provided enough information here. So this is the data set called Breathe.
Those are all journals. Those are all like someone was
yeah, these all look from journals. So it's probably something related to, let's see, some details. They have not provided a lot of information in here. It's also only 71 rows, so we can preview it to see what is happening in this. So Monte Carlo simulation, this is all about archive. This is all about, this all looks to me that it's collecting data which is around breathing. It collected all the different samples from different, like these are papers that are published on these different locations, and it has all those tables in all those papers in one single place. So you can look at what is available. So I think this is that. If I were to guess, this is what it is. Because I see medRxiv in here, I see Nature in here. So I think this data set is about all the papers, scientific papers that are published around breathing. And I'm assuming this was done as part of the COVID relief thing. This one has a lot of rows, 125,000 rows. Actually, let's try querying this. This is Nature. So it has a lot of lot of rows in here. It's looking for different categories. It's looking for a lot of categories, citations, dates. And this looks like good enough paper. So let's try to make a query on this. Sounds good? I'll assume yes, and I'm going to move forward. Okay, so let's do first a very simple query. The simplest query in a split tab, because I'm not familiar with the data, so I can look at it as well as I'm writing the query. Okay, so this is just so we also see what is happening in the view. So this is all table view navigation. This is how the data looks, and this is similar view, but now here I'm in a query view, so I can see exactly what I'm writing. The reason I have it in a split view is because I'm not familiar with this table, so I want to keep looking at the table to figure out what kind of query I'm making. And this here is an error because I don't have my query is not correct right now, so it will give me error. What I can do is I can just do select asterisk. So this is really bad query to write, but I'm just going to show you an example anyways. So we're going to query the whole database and list only 10 items. You see, it shows me right here that I'm not doing anything fun in here, and I'm not putting my data. There's no limitations on my data. I'm not cutting it off properly. So it's going to actually process the complete 6.78 gigabytes to give just the 10 rows. Not a good way to do it, but we're going to run it anyways, because why not? So query completed. We just finished querying on 6.5 gigabytes of data to get this answer here. And here are the 10 rows that it got, and I think it's just the top 10 rows that it returns. Yeah, so it's like top 10 rows that we are seeing. This is the second row, and similarly we'll see the third row in here as well. Yep, so it returned the top 10 rows. What you can do is you can also look at some job information in here. So this is the job ID. It was run from my user. This time was when it was started. It was created, job was created at this time. Start and end time are milliseconds apart. Total duration was 0 second. See, the thing is, bytes build is still 6.78 GB, even though it took 0 second. So just be aware of what kind of queries you are making on your table. If you actually just need to look at the table, just go into preview mode and you can see the table here as well. So really bad query, not a good query to make, but let's try to make an actually good query. Now, who knows how to write a good query? Because I don't. Let's see. I'm going to try to do acquisition date. Is it a date type? Let's figure out. Schema is type date. Okay, so we can probably use some queries in here. Schema acquisition date is, I actually don't remember now how to write these queries. Greater than, somebody help me here. Let's do a group by, that might be easiest. Okay. Let's see, there's a formatting in here. Format this, format the query. Okay, so this is much easier to see. And then I'm gonna do a group by in here. That is the easiest way to write this query. I'm gonna group by acquisition date. And I'm gonna just look at different acquisition dates. Yep, okay. So this will give us all, okay, so I should have shown it beforehand. I totally forgot to show it, but let's just do it once again. Can it show me some information here? Okay, so this is what I wanted to show you, that it will only process 980 KB of data because we have already asked, see, it was 6 some GBs of data. But since we are making a proper query, we are asking for only for acquisition date, and it's only going to group by acquisition date. It knows BigQuery is aware of how to perform optimization. So in this case, it is only going to look at this table, this column. It disregards everything else. So when the query is happening, it's only going to use 980 kilobytes of data. And for that, it ran the whole thing. So let's see in the job information, you will see some information about that. So it used 980 kilobytes. Still, the whole time that it took is 0 seconds. And it processed 10 MB. Oh, another thing about BigQuery is doesn't matter how small the data is, it charges you at least 10 MB. So even though we made our query very small, it still charges 10 MB of query, but the cost is really low. We won't worry about that for now, and we will come back later. But this is not really fun because like this is very small table, and even though I'm using a big query in here or trying to run it on large table, it's not giving me enough. It's not taking enough time. I want to put BigQuery through some stress for it to give me some proper data. So let me find one of my fun ones that I remember. Thank you for the suggestion in there, but let me see some large data set that I remember. I think it's the Hacker News one, and I'm going to try it in there. Let me just quickly see if I have a saved query for something. Oh, yeah, so this is the query one. So this is the one example that I know about from Hacker News table, which takes a long time or some time, not a long time. But let's first take a look at which one is it looking for? Full. So let's take a look at the table and then we will run the query. So this is the Hacker News table. If you're not familiar with Hacker News, let me just show you quickly. This is Hacker News. It's my home button, home tab. So you can see it as well. Hopefully it loads. I don't know why it's taking so long. You'll see whenever it loads. It's essentially a place where you can go in and it collects news from different sources. Wow, it sucks. Hopefully my call is actually properly working. Is it?
Yeah, you're fine.
Okay, I don't know why. What's happening to the Hacker News here? Okay, we'll see it later. Let's just take a look at it here. Okay, so there are 33 million rows in here, 12 gigabytes of data, and lots of data in here. Let's do a quick preview in here. Let's see when it was updated. November 16th, it hasn't been updated for a while. You see in here all the text that people put in here. Funny that it's right here already talking about AirPods. This is probably some, it's a comment on a post which was around AirPods. So this is all the information that you would see on Hacker News stored here. Let me see again why it didn't load. I want to show you how it looks in the UI so you can see.
I think it might be down because I just tried to get on too, and it's.
Oh, wow. Okay.
Is it?
Never rely on internet. So I don't have to, actually, this is a very good example. Right now, if I wanted to search something on Hacker News, I can't because it's down. So I can come in here and search here directly, even though it hasn't been updated for a while. But yeah, so this is the table. And what we're going to do is we're going to run a small query on this table. Let's see, saved queries. I'm going to query on Hacker News. And this is a query. So it's a simple query. We're getting all the information that we have. And we know that it's going to process all the tables. It's 12.59 GBs that it will process. And we're going to just run it. And what we are looking for is anywhere in Hacker News where BigQuery as a text has been mentioned. And we are only limiting to 1,000 responses in here. So let's run this query. When will it be done? Yes, now. Now. Okay. So it took 5 seconds to do this whole query. Let's take a look at the job information before we get into the results. Okay, 4 seconds to do the whole query total, 12 gigabytes of data processed. So this is the power of BigQuery. You don't have to really think a lot about amount of data that you're throwing at it. And that's the thing that I meant when I meant serverless and unlimited data storage that you can. And okay, let's see if it actually did the things properly or just returned the top 10 results rather than doing any actual text, any actual searches in here. So let's see, this is the text, and yes, it does contain BigQuery, just to make sure that it is actually doing things properly. Is another response in here, and let's see, yep, it also has BigQuery in it. So it's not returning false responses, it's actually doing the query properly. And you can play around with other tables as well. I think everybody gets the Cloud Skill Boost, and in Cloud Skill Boost, you should have some BigQuery samples in there. And like when you go to BigQuery, this is public data information available. After you are done with your actual class, you can just run another one and go through this, just try out different things. Don't do it on your account because it will incur charges. I think every account has $300 or something free. A new account gets some free, and I think there's 10 GB of queries are also free on BigQuery. But like if you run something like this, it will cost you 12 GBs directly right in one query. So probably try it on Cloud Skill Boost. But you can try it on different types of databases, and let me know if you run into terabytes of data to run this query. I think I have a terabyte example as well. Let me quickly check in if I have one. Native table, model prediction, GIS sample. Nope, none of these have terabyte. If somebody remembers which one is it, I'll happily run a query on that. But in case not, let's move on and we will come back to that in a second. Okay, so we just did the first table where we saw the BigQuery. We also saw the query, and we ran that. We also saw the BigQuery. So because it's a big database, we ran a BigQuery. We also saw that. Let's just go back in here and do some more things. So of course we can query on existing data, but I want to add my own data. An empty table is not fun. So let's try adding some data in here as well. So let's go, there's nothing more in here. I'm gonna create a new table. So let's create a new table. And this time, rather than going an empty table, I'm gonna actually upload a file. When I upload a file, I want it to use just that uploaded file to create table. Not really an amazing way because you don't really have a lot of files, but let's see. Like upload file has small limits. I have this file, hurricane data, over time. I'm uploading that. It's in CSV format. It automatically recognizes that the file is in CSV format. You can use other types of files as well. You can use Packet, Avro. I actually don't know what ORC is, but you can use that as well. So now a destination for this. Remember, the project is no servers, dataset is demo, and we'll create this. We'll call this hurricanes, because why not? Now, this will be a native table. We'll talk about what other types of tables are possible, but right now this is a native table. Native table means that BigQuery will take this file, it will upload it to somewhere that is accessible to BigQuery internally. It's not gonna be an external storage. Now let's try. This is the best thing that I like about BigQuery here, is auto detect the schema. I never have to think about the schema of this file. I haven't opened that file yet. We'll see if it works by just auto detect. Since I've asked it to do auto detect, it gives me sometimes some more options to see number of errors allowed. Should I create the table or append to the table or override the data in the table? So what is that? And then field delimiter, is it comma? Is it tab separated? Do I have to skip any header rows or not? So I'm going to do first an error case. I know that I have to skip a header row, but let's try with not skipping the header row. And let's create the table. So it's going to upload the file. So BigQuery does everything as a job. So it started that job, and the job is finished. Now it uploaded the data, and here's the data. And it is uploaded. So it's actually fine here. It's like it has the month in here, average in here, all the things that we needed about the table, all the things are in here. This is the same data set as the Dallas data set that we saw earlier. It just has the information about hurricane rather than the complete information, all the other information. Oh, so here's the issue. You see, it missed the first row. First row is totally empty because it has no idea. It didn't do things properly. It got the details, but it missed the first row. So we'll just upload this data again. So you will also see the delete of a table. So you can come in here and you can delete the table. Please don't delete tables at your work. It's very hard to get those back. But here we can delete it. Oh, nope, I don't want to delete. I wanted to add a new one, create a new table. So let's try to do that again. Same thing. We will upload, select the file, browse the file, hurricanes. Okay, and let's give it name hurricane. Okay, native table, auto detect the schema. But this time we know that we did something wrong, which was we need to have one header row to skip. It will skip the first row as the header row, and then it will use that as the header row. So now when we look at our table, everything looks fine already. This was already done properly. But in the details, in the preview, we will also see that, I hope I'm on the correct table. No. Oh, wow. Okay. Then there's definitely some issue. Maybe it's with my CSV file. I'll have to take a look at that. But it's very small data, 9 rows only. And again, we can query on the table, but there's nothing to query here. This is a very small amount of data. We can do averages. We can do calls. We'll do more things as we go in a minute. So actually, let's go there. Let's try to solve the problems of our friend Vikram, our friend Kiv. Vikram is me. I have to remember. So what I have is, let me show you another example. And before we go there, one example that I do like, and I know that I said earlier that you can't use, that you can't edit the data in here in BigQuery, but let me show you an example of how you can. So BigQuery allows you to externally connect your data. And in this case, we are externally connecting to a Drive sheet. So this is a Google Sheet that is in Google Drive right now. So this is actually supposed to be 1921. I'm just going to go back and just do the query. So this is the sheet. I'm going to come in here. I just need this ID. This is a sheet which has the data of, from Spotify, it has data about various information about different tracks. So this is the name of the track. This is an ID that is available to Spotify itself. These are different loudness, liveliness. I understand that it's not visible properly right now, and you don't have to worry about that. We'll come back in a second. So what I'm going to do here is, it needs the complete drive URI. Let's give it the complete URI. Okay, so this is the drive URL table, and we're going to name this Spotify coming from drive. And it knows that it's an external table because it's coming from Google Drive. We will let it auto-detect schemas and go down, advanced options right here. And it will take care of unknown values if there are unknown values. And it won't be imported. It won't crash the job itself. So, okay, starting that process. Oh no, corrupt data while trying to find the file. No, I don't know why it's corrupted. Let's see. That work? Sorry about that. I should have tested this. Oh, my bad. I know. It's looking at file format as Avro. It's not a file format Avro. It's a Google Sheet. And in the Google Sheet, we need to look at A2 till, what is the end range? Let's see, A2 to S. We'll go with that. This is the range, A2 to S. Actually, we'll just do A to S, and then it should figure out automatically the header range. So this is our table. We'll see if it can figure it out. A to S, that's our range, and it's going to create that. And if it doesn't, we will create a new table where it will be A2 to S. So it knows which one is the header column or not. Actually, I don't know if we had any advanced options. Oh, we did have advanced options. We should have looked at that because there's a header row in here. Okay, let's see it anyways. Spotify Drive. Oh, yeah, so it did not know. It didn't figure out any header columns. So this is it. We're going to delete this table because it did not get the data properly here. Delete this table, and then we'll create a new one. Create table. Just go with the same thing. I'm also showing you unintentionally that how easy it is to try to prototype around here in BigQuery. If you do something wrong, you delete the whole thing. It takes 2 minutes. Keep going. And we will go A to S. And we will go with Spotify Drive. Down. Auto-detect the schema, and this time we will tell it to skip the one header row. Both unknown values, not new lines. Let's jagged rows are available as well. So let's see how it works this time. Okay, it's taking some time. So now hopefully it's actually working properly because it's taking some time. When it takes time, I know that it's actually working properly. So, okay, let's see. Here it is, Spotify Drive. And this is our table. So, okay, all the data is here now. So see, what I didn't have to figure out is writing this whole thing. This whole writing of schema would have taken me so much time. And when the auto-detect part was not there, it was introduced, I think, 3 or 4 years ago. But when it was not there, it was such a hassle to figure out what is the type and like maintain that whole schema on your side. But now BigQuery has auto-detection of the types. And it did everything properly. It has the valence, which is a float, year, which is an integer in here, energy is a float, ID is a string. All these details are here. Let's go take a look at some details on the table. So in here, since we are not storing the table on BigQuery itself, we don't see any of the storage costs related. All the storage is happening on Google Drive. So that's where it's coming from, and the Google Sheet is the source. You can take a look at the source URI as well, and it skipped the first row as well from Google Sheet and took the complete A to S range. Now let's do a quick query on this. We'll query in I want to see. Oh, you also don't get to see the sample in here. So we'll query in a split tab. We will query top 10 rows just so we can see what is happening. But see the difference here. So earlier when we were querying data which was already on BigQuery, it was very fast. And that's the whole magic of BigQuery. When it's querying data that resides on its own servers, it's very fast. When it's querying the data that is external to BigQuery, it is generally slow. it doesn't do things as fast. So right now it's actually making the API calls to get the data from Google Sheets or Google Drive, load it into its own sections, and then run the query. So it's running, it's 24 seconds, 25 seconds still going on, and it will take some time for it to make the query and get the data. So we'll do a very simple query in here. Remember, this took 0 seconds last time, and now it's taking so much time. So while this is happening, we can go in and we can create another table where, because I don't want this slowness, we'll create another table where we will upload the data directly in here. But this time, rather than getting the data from local file, I will upload it from a Google Cloud Storage bucket. So let's go to a storage bucket. And this is my storage bucket where I have the file available. And this is the super secret music data that I want to upload. I know that the file is in CSV, so we'll use that. And we're going to upload it from there, from the source table. And this time we're going to call it directly just Spotify and auto-detect the schema, native type table. Just so you know, you can also use Google Cloud Storage as the storage backend. So right now I want it to be native type because I want the queries to be fast, but you can also use it as external. So the data will still stay on Google Cloud Storage. You won't incur BigQuery cost for the data, but the queries will be a little bit slow. I don't want queries to be slow, so I'm going to keep it native here. Okay, no partitioning needed. And we will do a number of errors. It's fine. Header rows. We will do 1 header rows and jagged rows. Jagged rows helps with saying that if you have missing values somewhere, it will still continue the job, because generally it requires all the values to be available. So load job created, we have the data in here. Oh, so our query finished. Let's quickly take a look at what happened in here. Go down, job information. Okay, so sorry about the clunk in here. Let's close this actually. Let's see if it can give some more information here. Okay, so this is the job information. It took 1 minute and 5 seconds. It queried 79 MB of data, total 80 MB is built, and it got the response for us here. And this is the result. It has 1921 and everything else. The thing that I wanted to show you here in the Drive one is I talked about BigQuery not being, you can't edit data in BigQuery. But what if you actually wanted to edit data in BigQuery? What you can do is you can connect it to a sheet, and then you can come in here, and in your sheet, you can change values directly here. So we are at the very end of the sheet. So let's go to the very top. 1921. I can convert this to 2022, 2023 in this case. And now when we saw a sample example in here, where is it? Query result. Query result did not have 2023 in here, but now if I query it, you will see 2023 as one of the results available in here. So it's essentially hacking the BigQuery so that you can get around the limitation of not being able to change the data. As this is running, let's open another one and run the same query on this table, Spotify actual table. So let's query this table in a new tab. In a new tab is fine. Let's do this. And we will see the difference in speed very quickly here. We asked for 10 rows. We already have the answer in here. It's completely done. And this is, remember, this is the one that is on Google Storage. From Google Storage, we uploaded it here to BigQuery directly, and that's why the query is so fast. And this is the older one, which is still running. And we will come back to it whenever that gets done. Now that we have Spotify data, so remember the problem that we're trying to solve for Give. Give wants to figure out, let's see, take a look at the table in here. So Give wants to figure out how, where's this, how popular that song is, because he wants to release popular songs. For that, he has few things that he can control. He can control the speechiness, he can control the tempo in it, he can control the loudness, the liveliness, the instrumentalness. He can control whether it's explicit or not. He can control the energy in it, danceability of the song. He can't control artists because he is one of the artists, but he can control some other variations in here. And of course, he can't control the ear for the song itself. So what he wants to do now is he wants to build a machine learning model which can predict the popularity of a song based upon if you give it all these different details. So if you give the song these different details, will it be able to come up with a high popular? Like, what if I make a song which has very high speechiness? Will it give me high popularity or not? You can test all those things by building that machine learning model. So that's the model that we will build for Give. In a minute, but let's first see if this is a written response. Oh yeah, so here's the response, and you see that the year 2023 is available in the data as well. So this is one way to get around BigQuery's limits of that you can't edit the data. So you can keep all the data in Google Sheet and use that to run the queries here. Another thing to note is this is right now running without a BigQuery engine. There's a product called BigQuery Engine, which you can add on top of a Google Sheet, which will allow, first of all, your Google Sheets to be really large, and second, these queries to be really fast. If you want to go with that way, where you give your organization or people in your team control over doing things in a spreadsheet, it gives you best of both worlds. It has all the data available in a BigQuery, in a big spreadsheet where you can make the changes and do all the things that you want to do in there and use formulas and anything else that you would like, but also use directly BigQuery on top of that whenever you want to run large jobs, and you don't have to export all the data out and in and all the jazz that goes along with it. Okay, so let me see if there are some other saved queries that I want to show you in here. So this is on a native. Okay, so yeah, let's do some proper query in here as well. So on this table, we will just do liveliness is greater than 0.98. So we're gonna take this existing one, and now we are, since our Kiv is a rock star, he needs to have music which has very high liveliness. So he's looking for some samples on what kind of songs are those which have high liveliness. So we got this here. There are some of the songs in here. I actually don't know, but if you know about these songs, please let me know. Sweet Georgia Brown, Helpless, Dream Live. I wish I was. That's my alter ego, not me, who knows enough about music. So these are all the different types of songs, and he can take a look around here to say, hey, high tempo actually is useful. Sweet Georgia Brown, even though it has high tempo and high liveliness, it wasn't really popular. It might also be a fluke because 0 is such a long information in here for a song that was out there for a long time. And yeah, so you can take a look and you can start figuring out what you want to do, and based upon that, start asking questions. But let's actually start making a machine learning model. So let's go to the actual part in here, just back to the slides for a second, and then we'll go back to making the model. So machine learning. Now, Kiv has seen some data. Kiv has some information about the data. He has the data into BigQuery. He wants to understand how to use that data for his own use cases, and I'll try to finish in the next 10 minutes. So now we want to use this machine learning to figure out how to do this. So what kind of machine learning tasks that we can do in this BigQuery, what kind of tasks that BigQuery allows. So right now, BigQuery only allows you to do linear regression, which means if you have a value 1, 2, 3, 4, it can predict 5, 6, 7, 8. That's linear regression in very simple layman terms. But it can do more complex things as well, but that's a easier way to explain linear regression. Binary logistic regression is when you want to say hot dog or not a hot dog. That's binary regression. Multi-class logistic regression is you have multiple rather than hot dog, apple, banana, and in between all of those, it can do a classification, multi-class logistic regression. So let's do some models. All right, let's create a model. To create a model, again, I keep forgetting these. That's why I have these queries in here, so we don't get into, I don't have to write the queries. So let's create this on our table. Okay, so rather than no servers and failsafe, we are going to go with our demo data set, just so you know it's the new one. And we're going to use, so this is the new part that is not in normal standard SQL. So just take a look in here so you can see exactly what is happening. We are creating a model which is called, this is the name of the model. This is up till this point, it's the data set. So this is project, data set, model name. So music model 1. This is our first model that we'll create. The model type is linear regression because we want to figure out the popularity. So this is the thing that we want to figure out. And what we're going to do is we're going to give it all the data from our demo Spotify table. It will use all the data from demo Spotify table to train the model on linear regression, where it will predict the popularity value, because that's what we want to do for Kiv. And let's start the process. We saw that it will use 33 MB of data, and now it's doing the actual model training right now. So this reduces all sorts of things that you would have to do to export this data into a notebook and to write queries there and to do model training, to learn TensorFlow, to learn PyTorch, or all the other things that you would. You can just come in here and start writing your models in just text, just a SQL query. We see it's taking some time because it's actually doing the training. So you can see execution graph in here as well. Okay, let's see. So it's doing some pre-processing on the data to clean it up, and then it will probably run multiple iterations on it to train it. I think it only does one iteration because the data is so small, it's 32 MBs. But let it run, and in the meantime, we will just take a look at what else is happening in here. So this was the query. Let's go through that query once more. The name of the project, name of the data set, which is failsafe, and this is the name of our model. We created a linear regression model on popularity because that's what we want to predict, and we fed it all this training data. So the training data is the complete table that we have. We gave it the complete table as the training data, and it's going to create that model. So let's see if we get if our model is done, and if it is, okay, so here's its model is done, the query is done, query completed. Let's go to our model. So this is our model. Just so we know, it's inside demo, models, music model 1. It was just created a few minutes ago. It's going to expire. Again, same thing. Everything inside this data set will expire on April 3rd. So it will do that. It's a linear regression model. It had 20 iterations to go through, but since it didn't have any data, it did only one iteration. Just so you know, you should never do just single iteration. So our model is going to be really bad. That's just a heads up. But you can force it and use a lot of different parameters in here to figure out how to do these things. And of course, there's an add in here to go from batch prediction to real time. Dismiss that. Okay, since there was only one iteration, we can see that it has a really high training loss. If you have seen any machine learning presentation, you will see this graph slowly going down and training and evaluation loss to come to some conclusion, some similar area. That's what you want. In this case, it's a very simple one, just one step, so it's high training loss. So the responses will be really bad. It took 10 seconds to do the first iteration. The learning rate is also high, 0.2. Learning rate will keep decreasing over time as well as we run through this model. So these are some simple things that you would, as a model developer, would want to see. Let's see some evaluation metrics. Mean squared error is so huge right now. It's really bad model. But what you're trying to do is get this mean squared error to really small, and you will have a better model. And I would leave this as an exercise for you, and I'm sure there are some Cloud Skill Boost workshops that you can do to get that out. What we are trying to do in here is we are trying to predict popularity based upon all this information that is given to us from the existing table. So this is our model. It has all these features. You see everything that is here, and now you can actually query the model. So I'm going to actually take an existing example so that I don't mess it up. Okay, and I'm going to query it on this model that we just created. Where is this? This is the model. I'm going to query it on this model. So here's the sample query. Let's format it so it's easier to read. And then I'm going to just keep it here so I can write the query properly. So we are taking it from the demo, and I'm just going to change I'm going to do the other way around. No servers, demo, and fail safe to demo. And rather than music, it's Spotify. Okay, so what we are doing is we are trying to look for, in this case, we are trying to look for all the songs that have the name Overture in them. And with name Overture in them, we want to figure out the predictability of how popular they will be. So that's what we're trying to predict. It's very simple to make these queries. You just use ml.predict in here. You specify the model that you want, which is in this case no servers.demo. That's the name of the model. And we're going to just, sorry, the model name is music model 1. This is just a designation to get to that model name. And we are going to feed it the Spotify data, just so you know that this is not really a good way. You should get some new data to test your model. But in this case, it doesn't matter. Not a very well-defined use case in here. So we're going to close that. Is there anything else in here? Okay, so our model actually finished running. So we actually have predictions in here. close. We don't want that. I'm just trying to get some space in here. Oh, wow, there's a lot of information here. Let's see. We'll slide it over. Okay. So here's our prediction model. So we actually predicted some things. So here's the predicted popularity of this song, which is done by My Fair Lady Orchestra. Where's the song name? The song name is actually just Overture. That's the song name. Wow. And let's see how good did our model do. So predicted popularity score is 11. And I think it's actually very different if we see the actual popularity score, which is also available here. Its actual popularity score is 25. So our model is actually doing really bad right now. But you can improve this. You can do all the things. And machine learning is a lot about iterations rather than just getting things done in one run. And that's what I will leave it up to you to figure out how to do, how to retrain your model better and get more things done. Let's just quickly go back to the slides. Okay, so just so we know again how to do the query, you do ml.predict, which is essentially using the ML APIs to predict on the model, which is specify its designation. In this case, the name is music model. You feed it the data that you want to run the query upon. And in this case, we made it a little bit smaller because we want to search only for when the name is Overture. Okay, so that's how you get the response out and you can start using it. So coming back, what is BigQuery? You can define it totally based upon your usage. You can use it just as a database. You can use it as a real-time analytics database where you are pushing the data inside it, and in the real time, you are seeing changes come up. You can use it as a GIS platform. I didn't show any demo for the GIS platform today, but you can use that as well. You can also use it as an ML model playground. The reason I have the word playground in here is because I generally suggest people to use this as a way to understand what the baseline model would look like on their data, and they just keep trying things out multiple times right here. Once they have a good enough understanding, and sometimes that model itself is good enough, but once you have a good enough baseline of your model, then you can start looking into investing more on data science tasks to build a better model. And then you know, like, hey, this is the baseline on which I want to build a better model. And it's much easier rather than going in, investing a lot of money and effort and your time into building a model, which you might have spent a lot of time to build, but it's maybe not as good as what BigQuery can directly build. Okay, so give it a go. 1 terabyte. Oh, 1 terabyte. Okay, sorry, my bad then. I said 10 GBs. I think it's like 1 GB of data, or 10 GB of data is free, but 1 terabyte of queries are free per month. So you can use that to run a lot of queries. And I would suggest starting with the public data sets that are available on BigQuery. And if you get into some responses and you want to share your results, use the hashtag BigQuery Madness and tag me as well, and I'll retweet it. Okay, coming back to Kiv. So Kiv now knows what to do. He can use that information, that model, to figure out what he should do, what kind of music he should be producing to become a really successful rock star. But the not so fun fact about Kiv is he's just a self-proclaimed rock star. He doesn't really know how to do it. So this is a demo of him. And he broke the strings. So he doesn't really know how to play music. He's not really good at this, so we are not going to stay on that. We're going to come back to you. Let's do some questions, and I'm here. That's it. Yeah, reach out to me on Twitter in case you don't have questions right now, but will later, and I'm out.
Thank you so much. That was so good, Vikram. I feel like even I learned stuff, and I use BigQuery like every day.
Nice. Okay.
So yeah, I agree with Rich. It was excellent. Is there anyone in the room or in the virtual room who has questions in our last few minutes today? Speak now. And I will say, if somebody thinks of something later and you can, tweet at Vikram, or you can post it in our Slack group, and I will ask him as well. So that could work too if you forget. But yeah,
Good question. Yes, I see the Meredith's question.
Okay.
Yeah. So yeah, we do actually use exclusively GCP for our business. for a long time, we were very heavy users of BigQuery and machine learning platform. I don't use BigQuery these days as much, mostly because most of the other teams do take care of that, and we have a better, a more user-friendly way to make queries. So I don't have to like write the SQL query by myself by hand, and you can just like drag, drop, and click on things to make the query. And like I don't really do a lot of things in there, but yeah, we use GCP for almost everything. So from as simple things as running a cloud service, running a VM, to running any machine learning jobs, any APIs that we use. Yeah, almost everything that we do on cloud is on GCP. And like since we are a SaaS business, almost everything that we do is cloud based. So yeah, we use it a lot for our business. Yeah. If you have any specific questions about our product, I'm happy to answer those as well.
I know there was a question right at the beginning when you were kind enough to post like the current jobs that you have.
Oh yeah.
Whether you have to be located in the US to apply for those jobs.
Yes, sadly, we are a very small team right now. We work in like this time zone. Actually, most of our team is located in Pacific time zone, and almost everybody is in the office right now. I'm actually in the office right now, so it's sadly yes right now. But hopefully in future we can change that.
Are there any other questions? I might have one or two if somebody else doesn't have a question. Do you know, for like we kind of quickly when you were creating data sets, like went over like you can select a region or not, right? And you know, most of like what I work in, we usually are in US Central 1, right? Do you have like an explanation or good explanation if there are other like cost or efficiency reasons why one would pick one region over another, or it just kind of
I can't say this with certainty, but as much as I understand, BigQuery, the way it works is since it's serverless, there. So the way BigQuery generally works is all the data is stored in their servers, and only when it queries, it asks for a specific row or column of information. And in that case, the computation and storage, they're like co-located but not really, because you shouldn't be looking at those details. So in the end, answer is I don't think there's a lot more that you can extract in terms of performance or pricing when you go with like a specific region or not. But it might be that if you are only doing queries on a specific region and a specific, like you are also in that same region, it might be a little bit faster. But again, in the grand scheme of things, it's not really a big difference, at least what we have found from that. I can take a look at like more details on this and get back to you with like a proper correct answer on this.
cool. Yeah, I think like that's probably some of the explanation I've had myself as well. Oh, and my only other question is, if BigQuery can handle lots of data very cheaply, what are the advantages of, or what would be some of the reasons why one would have a table expiration?
Why would people have table expiration?
Yeah.
The reason I generally have table expiration is because I wanna like I don't wanna pay for it after the demos are done. But some other examples would be, so for us, we have analytics data in our servers, which we store for a long time, but there are also other types of storage where you want to store it only for a certain amount of time. And like this is very much in the sense when as it comes to like more regulations around things. So there are companies which are only allowed to store, you get some information from user, but you're only allowed to store it for 7 days or 30 days or 1 year, stuff like that. So you can set an auto expire on the table or auto expire on the data itself. And the best way to do that is like use table partitioning, so that it deletes that partition of the table rather than the whole table. So that way you set the table partitioning and it keeps deleting the older partitions after every 30 days. So you only have 30 days of data. We use this for some of our logs that we do from our apps, because we release our apps or websites in such frequency that after 30 days, it doesn't matter what was released, and whatever logs we have collected, they are of no use. So we can delete them after 30 days. Yeah, so that way you keep the cost low, you don't have to manually think about going in and deleting older entries and stuff like that. It automatically takes care of all of those.
Cool. Any other questions? I know it's getting late for some folks, or even very, very early for some folks who are joining us from across the pond. Thank you so much for taking the time to come join us. This was great.
Yeah.
Again, if anybody remembers a question or something, don't forget to reach out to Vikram on Twitter, or you can send it in our Slack channel and I'll get it to him. Generally, I think it's late, so we'll call it a night. The practice questions and anything I had as backup in the slides today, what I'll do is I'll add like threads in our Slack channel of the questions and we can discuss. But I'll probably do that maybe tomorrow. So hopefully that's okay with people. I will also share the slides as well. And some people came in late. They wanted to know if they'll be recording. We have been recording, and I will also usually get that up on our YouTube channel and then share that in Slack as well. Yeah. So hopefully that's good for everybody.
Awesome. Thank you for having me here, Jessica, and thank you everybody for coming in. Yeah, any questions anytime, just reach out to me.
Thank you so much, and everyone have a great night.
Thank you. See ya.
Bye.